From ARUP Laboratories on the campus of the University of Utah, welcome to the LabMind podcast. I'm your host, Dr. Brian Jackson. Today is Wednesday, the 30th of October, 2024. For today's LabMind episode, we will be discussing clinical laboratory data and data analysis, but I promise you do not have to be an informatics nerd to get value out of this episode. We will keep it practical and non-technical. Our guest today is Dr. Jenna Reichert. Dr. Reichert is Medical Director of Operational Informatics and the Director of Laboratory and Clinical IT at ARUP Laboratories. She's Adjunct Associate Professor at the University of Utah School of Medicine. She received her bachelor's degree in mathematics from Boise State University and her doctorate in microbiology, immunology, and parasitology from Louisiana State University Health Sciences Center. Dr. Reichert served as a postdoc fellow at Mass General Hospital and Harvard Medical School, followed by a clinical microfellowship also at MGH. This is Dr. Reichert's third appearance on LabMind. Regular listeners may recall the episode we did together back in April 2020 on COVID antibody testing, as well as the episode in February 2022 on the impact of transgender medicine on clinical laboratories. Note also that Jenna Reichert has an upcoming webinar entitled Leveraging Clinical Laboratory Analytics, which will take place on December 17th at 11 a.m. Mountain Time. Any of you can sign up for this. There's no cost involved. Just go to aruplab.com for details. Jenna Reichert, welcome to LabMind.
Thanks, Brian. Glad to be here.
So do you consider yourself to be a data nerd?
Absolutely. How can someone with a mathematics degree not be considered a data nerd? My husband teases me about wanting data all of the time.
So did I tell you that I was a math major as well in college?
I think so. It
Yes.
is something we share in common.
So I totally relate to this.
One of the funny things about that, when I was working on my PhD, one of my professors actually pulled me aside one time and said, having that mathematics degree is really going to set you apart from your peers. And I had absolutely no idea what he was talking about at the time. But since then, I've come to realize that it really does set me apart sometimes. I have some language and some understanding of things that aren't typical always in laboratory medicine. So it's definitely made me an informatics nerd.
It feels like it was maybe during the 1990s that biology went from a almost entirely qualitative field to an extremely quantitative field. And how is that played out in microbiology? Because again, microbiology classically is all about qualitative. Look at the culture plate, look at this image of a parasite under the microscope.
True, but we all have to do operational research. Is our lab functioning the way that we intended? And there's always quantitative data behind that. Some of the things that we might talk about today is looking at textual results. That's certainly not quantitative, but there's plenty of informatics and data analysis that we can do on those types of data. So I think in the microbiology space, counting organisms, determining positivity rates, all of those things apply still. So I think even in those spaces where we're not talking about a clinical chemistry where you've got a nice AMR that you've got to work with, there's still plenty of opportunity.
As someone who spent a really long time training in microbiology, how did you come back to informatics?
Because I am that informatics nerd, I can't help myself. When I was at MGH during my fellowship, I actually was the go-to person to use Crystal reports to pull data out of the LIS. None of the other fellows or residents were even interested in doing that. And yet here I am. To me, it was fun.
I can totally relate. When I was a resident, my major research project was basically pulling microbiology data out of the lab information system. Yeah, not many people speak SQL, so it makes you a valuable.
Definitely. And if you think about another analytics opportunity in microbiology is creating the antibiogram, that is not a trivial endeavor.
No. Anyone that's tried this, it sounds straightforward. It is not straightforward.
It is not straightforward. Pulling the data out of the LIS is not trivial. It has a lot of complications. And then organizing the data in a way to get susceptibility versus resistance and getting the numbers organized, it's a multi-month process.
I hope the ID docs realize the amount of effort that goes into this because this is challenging. So we want to talk about some of your recent projects over the past couple of years. And one of these, you've been working on a data analysis project that's not in the microspace, but involving estrogen and testosterone assays. What can you tell us about that one?
We do a pretty high volume of testosterone and estrogen testing, and the test menu in this space has quite a few options in it. So, for example, we have testing for free and total testosterone. We have different methods. We have immunoassays versus mass spec versus equilibrium dialysis. So just figuring out which test is the one that I'm supposed to order on my patient is not easy. And what was happening was we were receiving a lot of questions from clients asking, which test am I supposed to order? Here's my situation. Part of the problem was that the way that we had named our test made it sound like the tests were exclusively for example, adult males, and that was the only patient population that it was appropriate for. And that just wasn't the case. But because of the names that we were using, that's how it kind of came across. Since non-binary transgender patients have a need for this kind of testing, that didn't come across very well either.
Even though they're quantitatively a smaller portion of the population,
Sure.
They get quite a bit of this testing, I would anticipate.
They do. And so just that naming convention that we were using, adult male versus female and children, was very confusing. And so we underwent this pretty large adventure to change the names of the test, change some of the charting comments to make it clear how to handle your patient population. And then the third thing that we did at ARUP, we use an exception handling process. So if for some reason an order comes in the door, someone ordered a test that was intended for an adult male according to the name of the test, but the order was on a patient that was registered as female, we had historically, over time, developed these rules where we would call the client or contact the client and make sure that this is really the test that you wanted and not the other test that we have. And that got kind of out of hand. There was quite a few exceptions that we were having to deal with in that space. So the question was, can we change the rules? Can we change the name? Can we go through all of this to make it better? And can we prove that all of those interventions actually worked? So the data that we're looking at is whether or not the number of contacts with the clients after the order decreased over time with that intervention. And that was a bigger adventure than we intended. As I mentioned, this testing is very high volume. So we already have, just if you count the number of orders in a year, we're talking hundreds of thousands. Then because of the way our data is structured, in order to get that comment of us contacting the client, that's a separate data pull. And that data pull was enormous, like 500,000 pieces of data. And then we had to mash the two together. That's not too bad. That's what SQL's for. But now we've got this humongous data set. And the hardest part is, how do we figure out which of those comments are actually relevant to the question at hand? That's when I pulled in an informatics student to help me out. And they tried all kinds of fancy machine learning.
So this is doing text analysis, right?
Yeah, text analysis. And so they were hoping to get into some really complicated textual-based machine learning approaches. Turned out all of those were failures. They didn't help us at all. The easiest thing to do was go find the most common words in the comments that we knew were relevant, and were not in the comments that were not relevant. It was literally an Excel adventure.
Counting words.
Yes, counting words.
This feels like a theme. My impression is particularly people who are relatively new to data analysis sometimes try to come up with the most technically sophisticated approaches when sometimes the simplest methods turn out to be best.
So we had a problem trying to make it overly complicated when a simple solution was actually easier.
Yeah, one of the first steps that I think most experienced data scientists use is just to get some basic summary statistics, plot out a simple distribution of what you're seeing there just to get a sense of what the data looks like.
Yeah.
And often that'll tell you where to go.
I think part of the issue for me, I was actually grateful she did do those kind of quick demographics. Data wrangling is some of the hardest part of doing data analysis, and knowing when you've got 500,000 lines of data, are there duplicates that I'm not aware of? That was an adventure because the data set included multiple different test codes. And so one person might have results or orders for both tests, and they're legitimate and they're not a duplicate. And so the clinical side and how she should think about it clinically, and then the analytics side, how do you check for duplicates? How do you make sure that you've not accidentally excluded the data or transformed the data in a way that's not meaningful.
It is a nice resource to have students available, though.
It is.
There is something fun about working with students.
Yeah, they definitely have a bright eye on looking at things from a fresh perspective.
So what was the bottom line on the testosterone estrogen?
The intervention worked spectacularly. We had a drop of 98% in those relevant accepts.
So the specific intervention was?
The specific intervention was change the rules. Make it so that if a client orders a test and the test is intended for an adult male because it's the immunoassay for testosterone that has the right reference interval for that, then if the patient is a female, that's okay. Let it go through. The only change to the rule that we kept was if the patient is a pediatric patient, so less than 14 for males and less than 18 for females in this case, then we would still do a double check on age.
Yeah.
That actually turned out to be interesting. I was just looking the data over yesterday again, and it turns out we actually have a problem with our clients making sure to send us the correct date of birth.
Oh.
So now we actually have to go back and contact clients because we didn't get the right date of birth or it didn't make sense or there wasn't one at all. And so we have to go back and check that they're not a pediatric patient. So totally different problem that we now have to solve.
So one thing I really like about this estrogen testosterone example is that it's going back to the pre-analytic, which laboratories don't do terribly often. We often just take the orders that come into the lab as a given, and then we manage the quality from there. But we know there are a lot of errors that can happen in test selection. And I think this is a great example of sort of touching that space.
Yeah, it was a fantastic, fantastic project. I had a great time.
Let's pivot a little bit to a different kind of analysis. I understand you've been working on some novel quality control related things within infectious serology. What can you tell us about that?
Yeah, so in serology labs, we have created these Tableau dashboards that are essentially tracking and trending positivity rates for all of our serology assays over time. The beauty of it for me is every month I just get an email. I click a link, it takes me to the dashboard, and I can compare how does this month look to last month. And because it's all of the assays, I can compare things across. So for example, we have quite a few coccidioides serology assays. We have IgG, IgM, we have serum, we have CSF, and then we have a couple different methods, immunoassay, immunodiffusion, complement fixation. So all of those combinations with that positivity dashboard, I can start to kind of see, wait a minute, I see that the CSF positivity rate is going up, but nothing else is. What's going on?
So obviously there is a sudden epidemic of encephalitis, correct?
No. And this is what I love about these dashboards is it's going both to me and the laboratory. So I can just send them a quick message to say, can you check what's going on here? Is this patient population? Is this one patient that had multiple tests? Most oftentimes that's the case. We have one patient, they had multiple tests over time, and it just happened to build up. The total number of tests is small.
Threw the numbers off.
Yeah, threw the numbers off. Yeah. So this is not rocket science, right?
But what are the main things that you're looking for here?
Yeah, so I'm really just looking for comparing positivity first over time and then between assays to see is there an epidemic that is starting to pop up? Is something going on?
Which theoretically could happen in microbiology.
Theoretically,
in infectious
could happen.
Disease.
Is there something going on with the assay? So interestingly, I actually had someone from a different institution contact me and say, hey, our Coxi positivity rates seem to be going up and up and up. Are yours? First of all, I could easily send them a screenshot of our graph, and so we could kind of compare numbers really quickly. That was helpful. And then as I kind of dug into it, I said, to me, this looks like seasonality, not an issue. We were sharing the same kind of reagent kits, so we knew we were talking apples to apples. And when he went back and looked at his data again, he said, oh, no, I think you're right. This is a seasonality issue. And that was that. It was such an easy conversation to have.
Yeah. But sometimes it does reflect a problem or a change in the reagents coming from the manufacturer. The labs often aren't informed about, and maybe in some cases the manufacturer doesn't even know about it.
Right. We've had a couple of situations. Serology, it's very common, especially fungal serologies, for a slight change in the way that the capture antigens are made or whatever, that you get a funky lot and you don't realize it's a funky lot until multiple lots later. And having that kind of trend over time is super helpful. And having the lab be able to, we're not relying on these positivity metrics on a day-to-day, run-by-run basis. This is just an extra quality check on top of all of that to kind of smooth out the numbers over time. And it really is helpful.
I remember many years ago, so about 20 years ago, when we began to receive a bunch of complaints from public health agencies, basically saying, why is your hepatitis A IgM rate so high? Because all of these cases we're investigating turn out to be false positives. And it turned out that the manufacturer had basically tuned up the sensitivity and tuned down the specificity. And I don't think they'd been terribly upfront with their customers about that.
Yeah.
But this is an example where if we had been doing the kind of proactive monitoring that you're doing now, we would have picked it up before the downstream clinical data users were picking up on it, and it would have been really helpful.
Yeah, it's such a simple tool. It really is.
I know actually a lot of the chemistry labs do similar analysis and have been doing for years. I think this is maybe a little bit newer in the infectious disease space. But I'm not aware of any national guidelines or standards requiring analysis of these distributions. For example, median monitoring is a phrase that we use in the chemistry labs. Does this get done by a lot of other labs?
Actually, that's an interesting point that you bring up. I think just yesterday I was watching a webinar on AI and machine learning. And one of the discussion points was about moving medians and tracking moving medians. And they actually mentioned there's a CAP checklist item on this.
Oh, good.
Which I was very surprised to hear.
So that's new.
Hopefully that's true and I understood correctly. And I'm not telling health listeners the wrong thing here, but I think kind of this concept of monitoring over time is picking up some speed.
Historically, obviously, we do quality control with control samples, which aren't always representative of patient matrix. And there's some things that can slip through that. A reagent batch change may not budge the control samples, but may have an impact on the patients, which patient results are obviously all over the place. But if you summarize a large enough number of them, then you can see a change in the median.
Yeah, absolutely.
And it's a good thing that more awareness of this seems to be getting out then.
Yeah, now let's find a way in the community to create tools for your average community hospital to be able to monitor those things, right? Because I have a team of software developers who can create an app for that, but certainly not everyone does. I'm lucky in that way. So wouldn't it be nice if there was a tool that you could just easily get to as part of your LIS, for example?
Yeah, the LASs should really build this into their QC modules.
Yeah, that would be nice.
Another little point, picking up on something you just said a minute ago. You said you were watching a webinar.
Yeah.
And it was an AI webinar, but it was talking about moving medians. Why do you need AI to monitor moving medians?
I think that was kind of the brilliantness of this particular webinar. The bottom line was we are all doing fancy algorithms all the time. We already have AI and ML in the clinical lab now, and it's been there since 2015-ish, 2011-ish. We kind of get caught up in the Chat GPT rage right now, and it's easy to think that we're not doing these very fancy, complex analytics, and we are. That's what I loved about that particular webinar was just that the point was, yes, there is a place for machine learning, but we're already doing many of these fancy algorithms, whether they're trained or untrained and all of that sort of thing. And it was a really great webinar.
And for something like watching whether the medians are moving over time, you don't actually want to filter that through some really opaque AI kind of thing. You want the direct calculation so that you can trust it.
Right. Having a rules-based algorithm that you know what the output is supposed to be from the beginning is the better choice. Absolutely.
The simplest calculation is usually the best.
Yeah.
Okay, so let's pivot yet again to a completely different type of data analysis, really more on the lab management side and compliance side, I guess. Tell us about some of the analysis that you've done with John Gentzen, who's AirUP's Chief Medical Officer.
John and I are both interested in clinical laboratory regulation, and we have been contributing to the discussion about the role of the FDA when it comes to regulating laboratory-developed tests.
Hot topic?
Very hot topic. So we put out a paper last year. The basic question was, how often are lab-developed tests ordered in comparison to FDA-cleared or approved tests? Like, what's the relative volume of these things when just if you look at test orders. I think sometimes we find in the discussion that the most common way to talk about it is there's this many LDTs on the market. Well, there might be 1,000 LDTs on the market, but if they're only used 0.01% of the time, that's a kind of different perspective on looking at it.
Right. And FDA has definitely been portraying the LDT issue as being much larger than I think we felt like it.
Yes, exactly. So that was the basic question is, what's the relative volume of LDTs versus FDA testing? And then we had some kind of side questions about, are there certain specialties that order more? Those kind of questions. So because AREP is associated with the University of Utah, we basically took all of the orders over a single year from the University of Utah Health System, which we included University Hospital, the Huntsman Cancer Institute, all of our outlying clinics. So pretty broad look at the health system. And we took that order volume for every single test that they ordered, that whole health system ordered, and then combined it with data we keep as part of our test menu. We track which tests are FDA cleared or approved versus a lab developed test. And so we just mashed those two pieces of data together, went and saw, what is the volume? Well, it turns out it's 3.9% in our setting. That's pretty darn low.
Yeah.
Really low.
Yeah. So all the manufacturers out there who are afraid that LDTs are eating their lunch.
Yeah, they're not.
So for listeners who want to actually pull that article, we'll also put a link to the article in the show notes. Now, thinking about these examples, and these are, I think, great illustrations of different kinds of projects across the spectrum of laboratory management and quality management. I can imagine some of the listeners may be thinking to themselves right now, yeah, this is great for you because you have this huge IT department and a lot of resources, but not everyone has all those resources. So for a laboratory, an academic lab, a community hospital lab who doesn't have a whole bunch of data analysts at their disposal, can you speak a little bit to how applicable any of this might be in the real world?
During my fellowship, we kept a running tally of the flu and RSV positivity on a whiteboard outside of the virology lab. And I looked at that thing every single day during the winter season. It doesn't have to be complicated. I use Excel constantly. I speak SQL a little bit. I don't speak Python or R. So I think that anyone with Excel in their back pocket really can do a lot of the things that we're talking about. You don't have to have fancy Tableau dashboard. You don't need to have those AI or ML fancy tools. It can be pretty simple. And my greatest advice, if maybe Excel isn't your best friend, the two most important things to learn is how to create a pivot table and how to use VLOOKUP. Those two things, they can take you pretty far.
And there are tutorials available. And honestly, YouTube is everyone's friend these days
Indeed.
for looking up how to do stuff. So don't be afraid of complexity here. But this actually brings up an interesting point because when we think about laboratory data, I think most people just immediately equate that with the lab information system and doing everything within the lab information system. But how often for these kinds of projects do you need to pull data out of that and put it into something like Excel or some other format?
I think for me, as you mentioned, since I have all of the resources at my disposal, that's my quick go-to, but it certainly doesn't have to be. I think people oftentimes think because we live in such a digital world, everything needs to be maintained digitally. But oftentimes, like the whiteboard at the hospital that I worked at, tracking things simply and on paper is just fine. And pulling things out of your LIS can be as simple as you going and looking up the information and writing it down. Yeah, that's brute force and it's not fancy, but
for small volumes of data.
Small volumes, why not?
One of the messages I'm getting here is it's not that there are these certain magic platforms that you have to be expert at.
No.
But there are general purpose data analysis tools available out there.
Absolutely. And I think the more of us that use those tools effectively, the better.
But it's mostly, don't you think, about just sort of getting your hands dirty?
In a previous life, I used to be a math teacher. And I used to tell my students.
What grades?
I taught 7th, 8th, and 9th grade algebra.
That is intimidating.
Yes, indeed. I would tell my students, if you're working on a problem at home, doing homework, and the problem is taking you more than 5-10 minutes, you're probably not approaching it in the way that I'm intending you to, right? So come back, ask some questions.
So I know that you are a member of the laboratory LOINC, LOINC committee. I'm hoping listeners are familiar with LOINC, but if you're not, you'll find out in just a second. How does LOINC play into all of this?
Yeah, so when I first heard about LOINC, it was love at first sight. Essentially, the premise of it is in laboratory medicine, for every lab test, there's a code, just like ICD-10 codes, for example, or CPT codes for billing. And I think what's fantastic about it is you can describe a test based on the analyte, the specimen type, if it's quantitative or qualitative test, how the result's going to come out. Is it a presence or threshold, or are you identifying, or is it a mass concentration? It's a simple set of quick questions you can ask to identify what a test is, and then you can put a code to it. And then the brilliant part of putting a code to it is when you want to go pull that data out of a system, you can query the data so much easier. You don't have to know the exact test name, because certainly the test name at ARUP is going to be different than at Quest or LabCo or
Exactly.
And so it makes it much easier to aggregate data over multiple sites.
A simple example would be here. Suppose you want to download all of the glucose results from your lab.
Yeah.
But there may be multiple different glucose assays being run in different parts of the organization.
Correct.
There may be named all different things.
Yep. And the one downside of LOINC is it's not in a hierarchy. So there isn't an overarching code that will give you all glucose tests. SNOMED, on the other hand, which SNOMED is kind of if LOINC is the question, SNOMED is the answer. So for example, microorganisms are coded via SNOMED. Positive, negative, that can be coded in SNOMED. Specimen types can be coded in SNOMED. And so in SNOMED, it's arranged in a hierarchy. So if you wanted all of the microorganisms that are gram-negative, you can just pull all of them in one quick query. It's amazing.
And if you want all of the E. coli's, you can pull those. And if you want all the E. coli 0157H7.
Yep. I'm actually using this concept in a new project that I'm working on. There is a resource that just recently became available through the National Cancer Institute. It's called the COVID Real World Data Infrastructure. And the basic idea was to put together COVID laboratory data, pharmacy, vaccine, and medical data so that folks like me and you who are analytic nerds can go in and mine that data and ask questions. So the questions that we're asking in this particular project is vaccination less efficacious in patients who have inflammatory bowel disease, especially those who are on immunomodulators? So we can use LOINC and SNOMED and ICD-10 codes to basically go in and query this very large 5.5 million patient database and pull out just those things that we need. It's absolutely brilliant as far as I'm concerned.
But you can see how that would be a really hard project if you didn't have the LOINC and SNOMED codes.
It would be very hard.
Because looking up 5+ million medical records and reading through them individually is just not going to be realistic.
Not going to be realistic. And the other thing, these platforms that are available nowadays for kind of harnessing these kinds of big data sets, the typical strategy is someone builds the big data set. In this case, it was the National Cancer Institute, along with some other folks, some folks from Northwell, for example. And they put together the data set, and then they put it in a way so that you can first just say, here's my research question. Is there even a cohort within this that has enough people in it for me to actually do the research?
Yeah.
So we've already gone through that first initial analysis. Plenty of patients. We're talking about something like 1,000 patients who are on adalimumab that have IBD, that we can collect COVID testing data, vaccine data, medical claims data. I think it's going to be an interesting project.
Excellent. Do you have a sense of how widely LOINC and SNOMED are being used?
It has really been picking up lately. So my team is the team that maps all of our tests to LOINC and then puts it into our LIS and distributes it to clients. And we typically get requests for two reasons. One reason is that at the client site, when they go to build the ARUP test in their LIS or their EHR, they need that mapping. The most common reason they need the mapping is for public health reporting. So the CDC has really upgraded the way that they are pulling public health data, and they need it to be mapped to LOIC and SNOMED in order for all of the rules engines that they have in the background to actually work. So that's the number one request. And then the number two reason why people want it is this idea of the data analysis. They want to be able to pull things out of their LIS or their EHR in an easy way.
So final question, what's your retirement plan when AI replaces all of us?
I don't think AI is ever going to replace us. There's always going to have to be humans in the loop. And I can still go back and use my Excel tools and get a lot of things done.
All right, Jenna Reichert, thank you so much for being on LabMind again.
Thank you for having me.
LabMind is sponsored by ARUP Laboratories, a not-for-profit enterprise of the University of Utah and its Department of Pathology. Our producer is Cherie Peterson, with audio engineering by Isaac Acosta Alvarez. You can also find other LabMind episodes at arup.utah.edu, along with an extensive video lecture library providing free CME and CE credits for medical and laboratory professionals. Subscribe to LabMind on Apple Podcasts, Spotify, or your other favorite podcast app, and please leave a rating and review in order to help others find the podcast.